Hey everyone, welcome back to another Prep video. And in this video, we're going to tackle the tabular method, which is also has other names such as the DI method or the Tensland method. And basically, what this method is just a faster and easier way of performing integration by parts. Because as you may know, integration by parts is a really lengthy and tedious process sometimes. So the DI method or the tabular method helps make that much easier. So let's say we wanted to find the integral of x squared sine of x dx. First, before applying the tabular method, let's try doing the actual integration by parts formula. So we're going to let x squared equal to u. So this is going to be the integral of x squared. And dv, we're going to keep in this case as sine of x. And according to the formula, that's going to be the same thing as u, which in this case is x squared, and v, which is the integral of dv, and the integral of sine of x is negative cosine of x. So we're going to write negative cosine of x here. Okay, and then that's going to be minus the integral of v, which again is negative cosine of x squared. Sorry, just negative cosine of x. And du, which is the derivative of x squared, so that's just 2x. Okay, so now let's just simplify this a bit. So we see here that there's a negative and a negative, so we can just remove this negative and make this a positive. And we can, instead of putting the negative over here, we can just put it in front of the in front of the x squared. And I think that seems about it. So now we have to solve this integral over here. What is the integral of cosine of x times 2x? Well, we have to use integration by parts again. So we see here that this is going to be the same thing. This all is going to be the same thing as negative x squared cosine of x, leaving the same thing here, plus now we have to solve the integral of cosine of x times 2x. So in this case, we're going to keep cosine of x as dv and 2x as u. So that's going to be the same thing as uv. So u is 2x, and v is the integral of cosine of x, which is just sine of x, minus the integral of v is just sine of x, and du is 2 because the derivative of 2x is just 2. So we can just plug that 2 right in front of the sine of x. And then we can finally simplify this to be equal to negative x squared cosine of x plus 2x sine of x minus the integral of 2 sine of x is just a negative 2 cosine of x. So that we can just get rid of the negatives over here and make this plus 2 cosine of x. Okay, so I think we can see that we solved this integral over here. But now let's start applying the tabular method to this. So I'm going to keep this answer over here so we can compare our answer after we're done with the tabular method. So now let's start the tabular method. So what we're going to do first is draw a few columns. On this side, we're going to write derivative. And if you want to abbreviate that in some way, that's fine. And on this side, we're going to write integral. And again, you can abbreviate this. Okay, so let's see how we can apply the regular integration by parts formula to this. So it seems like when we're using this formula, the u, we always find the derivative of u in some place, and we always find the integral of v. So maybe that means that whatever we keep as u must go in the derivative tab or column, and whatever we keep as v or dv goes in the integral column. So in this case, in the previous integration by parts example, we saw that x squared was going to be the derivative, is going to go in the derivative section. And then the sine of x is going to go in the integral section. And here, what you're going to do is draw a separate column and just keep on alternating pluses and minus. Okay, and we're going to see how that comes into play later. So now we just keep on finding the derivative until it becomes 0. So the derivative of 2x or x squared is 2x, and the derivative of 2x is 2, and the derivative of any constant, in this case 2, is 0. So now we're going to find the integral all the way down till here. So the integral of sine of x is negative cosine of x, and the integral of negative cosine of x is negative sine of x. And the derivative of negative sine of x is just cosine of x. Okay, so here comes the magic part. We already have our answer over here. And what we're going to do is we're going to combine the diagonals, keeping the sign in mind. So the integral of x squared sine of x is going to be equal to x squared times negative cosine of x. So we can just rewrite that as negative cosine of x squared, and minus 2x times negative sine of x. And the minus and minus cancel each other out, so that just leaves us with plus 2x sine of x. And then we go to the next one, positive 2 times cosine of x, which is just plus 2x. Plus 2 cosine of x, sorry. And there we have it, our answer. And of course, plus c. Don't forget the plus c, eh? I forgot the plus c. Oops. So this would be our answer for x squared, the integral of x squared sine of x. And now let's compare to make sure that it matches up with what we had before. And if we compare, that actually does match up, meaning that the tabular method actually does work. So we see here that one of the cases where we can apply the tabular method is when we know that the derivative of one of the terms in here is going to end up becoming 0 eventually. So I hope you guys understood how we could apply the tabular method to certain integrals, and then we'll look at more cases in the next few videos.